Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Offset 3 by CRWN, or I think it's Crown? It's maybe. Maybe it's just like CRWN as just the letters, but let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have cells separated by a knight's move in chess cannot have the same digit. So, for example, whatever digit is in this cell, in addition to not having repeats in any row, column, or designated 9-cell region, there are also 8 other positions where you cannot have that digit, which would be in these 8 positions, which are a chess knight's move away. And that is also, it's called knight's move or anti-knight rule set. So just to let you know. And basically you can't have repeats in the cells that are a knight's move apart. So that's an example of how anti-knight works. We have thermometers, where numbers on a thermometer strictly increase as they move away from the bulb. So as an example, you could have something like, say, 6, a color. No, not a color. 6, 8, 9, and this would be valid because it's increasing from the bulb to the tip. And that's an example of how thermometers work. We also have arrows, where numbers along an arrow sum to the number shown in the circled cells. So, for example, say this was a 3 and a 3. Then this digit would have to be a 6, because the digits along the arrow must sum up to the digit that the circle that it's attached to. And that's an example of how arrows work. We have quadruples, where every digit in a line-bound white circle has to be assigned to one of the 4 surrounding cells. So these are the line-bound white circles. These are obviously not line-bound white circles. These are in cells. So the line-bound white circles means every digit that's in it, for example, in this case, 5, 7, 8, 9, must be in one of the 4 surrounding cells. So that should be kind of intuitive about what it is, right? 1 of 5 has to be in the 4 surrounding cells, so does 8, 7, so does 8, so does 9. And those are how quadruples work. And these are the next 2 rules that I'm kind of curious about because I've never run into them, so I'm curious to see how they work. We have offset quadruples, where every digit in a cell-bound white circle has to be assigned to one of the 4 orthogonally connected cells. And what are orthogonally connected cells is just the cells that share an edge with that cell. So for this cell, 2, 4, 5, and 9 have to be in a cell that shares an edge with this cell. So it's like the quadruples, the normal, and these are also known as quad circles. But basically, it's similar to quad circles, except that it's basically cells that share an edge with the cell versus cells that are touching the circle in for the quadruples. So, for example, the 4 cells surrounding this cell here must have a 2, a 4, a 5, and a 9 in one of them. This is 2, 3, 4, 5, and this is 3, 4, 5, 7. We also have offset odd circles, where the 4 cells surrounding a line-bound gray cell have to be odd. So basically, all of these must be odd, all of these must be odd, all of these must be odd, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first things first that I see is to make things easier, I'm going to highlight the cells that must be odd. That will give us some information about what can go where. So surrounding this cell, we know there's a 2, a 4, a 5, and a 9. Well, these are both odd, so this cannot be 2 and 4. This digit cannot be 9 because it has 2 digits greater than it, and 9 is the largest digit, so that's not possible. So this must be 5 here, and this is 9. That leaves the remaining 2 digits in that surround this offset quadruple as even. Same here. This is 2 odd digits here, so it's a 3-5 pair, which means these 2 digits must be even. Also, we have 5 odd digits in the central box, so these must then be not odd, and they're even. Let's see. This has 2 odd digits here. That's not helpful. Right. So this must be a 2-4 pair here to be next to this this offset quadruple. This is 3 and 5 in these cells to be an offset quadruple. This is 2, 4, 2, 4. There has to be 5, 7, 8, 9 surrounding this quad. So the remaining digits are 1, 3, and 6. This is an odd digit, so it's 1, 3, and this is 1, 3, or 6, 1, 3, or 6 here. To add up to 9, 1 would have to add up to 8, 1 and 8 would have to add up to 9, and 3 and 6 would be 3 and 6. This must be 6 or 8 here. Surrounding this quad is 1, 3, 4, and 8. Well, where is the 8 going to be in row 3? Cannot be here because of the 1, 3, 4, 8 quadruple in the box. Can't be here because of the 5, 7, 8, 9 quadruple in the box. Can't be here because it's odd and 5. This digit has 2 digits greater than it. 8 only has 1 digit greater than it, so 8 cannot be here, so 8 has to be here, and this is even. This must have 4, 6, 7, 9 surrounding it. So in this upper left-hand box, the remaining digits are 2, 5, 6, 7, 9. Obviously, 5 cannot be any of these digits because of 5 in the row. In this lower left-hand box, remaining digits are 1, 2, 3, 5, 8. And again, these digits have to be specifically 3 and 5 because they must, 4 and 7 don't fit this because they're surrounding this regular quad circle. So that eliminates 3 and 5 here. This can't be 3 or 5. This can't be 3 or 5. This is an odd digit. Cannot be 2 and 8, so this is 1. Which means this can't be 1. This can't be 1. We know in this upper left-hand box, 5 has to be one of these 2 digits here. That eliminates 5 from being here. So this is not 5. This is 3, which eliminates 3 here. So that's 5. So these are both even. This cannot be 4 or 6 because this must be odd. It's 7 or 9. These have to be 1, 7, and 9 here. And obviously this can't be 9 because of 9 in the row. This can never be odd. And the reason why we know that is if this were odd, that would give 5 odds in this box, which would force these to both be even. And 2 evens can never add up to an odd digit. So this can never be odd, therefore it's even, which means to add up to an even digit, you either need 2 odds or 2 evens. If you have 2 odds here, that's 6 odds in the box, so that's not possible, so these are both even. Which means one of these is even and one of these is odd in column 6, and one of these is even and one of these is odd in column 5. Interesting. This must be a 4-7 pair here to surround this offset quad. To add up to 6 cannot be 2 and 4 because that would eliminate all possibilities for the cell. It would have to be 1 and 5. To add up to 8, it could be 1, 7, 2, 6, or 3, 5, and any of those work. This must be an even cell to add up to this. So this has to be 6 or 8. And we're guaranteed this is 2 and 4 or 2 and 6 to add up to 6 or 8. So we're guaranteed a 2 here, which means this cannot be 2 here. This is 8. This cannot be 8 here. It's 2. 8 eliminates 8s from column 1. So that means surrounding this quad, we need an 8 here. 2 eliminates 2 in the rest of column 3. So this can't be 2, which means this must be 2 here. That 2 eliminates 2 here, so this can't be 2. This is 4, which makes this not 4. That's 2. So this can no longer be 2, so this can no longer be 6 to add up to 8. This is 6 or 8 here. Interesting. We know, so these are all 5, 6, 7, 9. We have to have a 4 and an 8 somewhere here in column 3. So 4 and 8 both have to be one of these 3 cells. Whereas 2 in this left central box cannot be here, cannot be in the odd digits, so it must be here. Okay, where's 2 in row 8? Cannot be here because of 2's in the box here and having to be here. And it can't be here, so 2 has to be one of these 2 digits here. And then we have cells separated by knight's move. Okay, knight's move. We know we have a guaranteed 2 here. If this is 2, that's a knight's move from that cell. If this is 2, that sees that cell by being in the same column. So this cannot be 2. Therefore, this is 4, which eliminates 4 here, so that's 2, which eliminates 2 here. So that means this must be 2 here. 4 by knight's move eliminates 4 from being there, so this is 2, 6, which adds up to 8. 8 eliminates 8 here, so this is 6, which eliminates 6 here, so that's 8. This can't be 8. So this must be 1, 7, 2, 6, or 3, 5. 9 eliminates 9 here by knight's move. So where's the 9 in the central box? It must be here. 5 eliminates 5 here by knight's move, and so is 9. So this can't be 5 or 9. 4 and 7. 1, 4 has to be here, and the 7 has to be in the other cell. And they both see this cell, so this can't be 7. This must be 9. So 9 cannot be any of these cells. It also cannot be here. 9 cannot be here or here. Or here. So 9 has to be one of these 2 cells here. Okay. This cannot be 1, 7 adding up to 8, because that would eliminate all possibilities for this cell here. Cannot be 3, 5, because that would eliminate all possibilities for that cell there. So this must be 6 and 2. So this is 6, this is 2. Those are both even. 4 can no longer be here. That means this can't be 2 here. That leaves, oops, 2 as only being there in column 9. Or box, row 8. Sorry, I should say. 2 in row 3 has to be one of these two cells. So this can't be 2 here. Therefore, where's 2 in column 4? Cannot be here because of 2 in the boxes. Can't be here because of 2 guaranteed here. Can't be here because of 2 in the row. So this must be 2 here. That is even. 4, where's 4 in box, in this lower central box? These are all odd, so can't be there, so 4 has to be one of these two. Okay. What else do we have? This must be greater than 5. And it cannot have a 9. So this has to be at least 6. This has to be at least 7. This must be at most 9, and this is at most 7 here. Where is 6 in this column? Can't be here because of 6's in the box. Can't be here because it's a 5. Can't be here because it must be... It must have a different... If it were here, it must have a digit between that and 5, and that's not possible. So this has to be 6 here. That's an even digit. That eliminates 6 here. This 6 eliminates 6 here by knight's move, anti-knight. This can no longer be 6 because of 6 in the row, so this can't be 3. This is obviously odd. This digit is at least, at least 1. This is greater than 1, but it cannot be 2, so it's at least 3. This is at most 7. This is at most 6, cannot be 6, at most 5, at most 4. Can't be 5 or 4, so this would be only 1 or 3. This could be 3, 4, no 5 or 6, up to 7. So we have a 1, 3 pair in row 3, which eliminates 1 and 3 in the rest of the row. This can't be 1. This is 6 plus 3, adding up to 9. That eliminates 6 in the rest of the row. This can't be 6. We have a 2, 7, 9 triplet in this upper left-hand box, which eliminates 2, 7, 9 in the rest of the box. So this cannot be 7 or 9, it's 5. This cannot be 5, 7, or 9, it's 6. This can't be 6 here because of 6 in the box. So this is even. This must be odd. These two are odd. This is even. Remaining digits in column 3. We have 4, 7, 8, 9. 9 obviously can't be here. This can't be 4. This digit is odd. So this could be 1, 3, 5, or 7. No 5 because of 5 in the column. Okay. 8 cannot be here. Where is 8 in this right central box? It has to be one of these two digits, which eliminates 8 in the rest of the column. So this cannot be 8 here, which means we have an 8 in one of these cells here. These are then both odd. This is odd, obviously. Where is 8 then in column 7? Can't be here because these are filled out. 8 can't be here because of 8 in the row. And this is 1, 2, and 3. Actually, let's just fill the remaining digits of column 7. We have 4, 5, 7, and 8. This can't be 8. This can't be 5 or 8. This can't be 8. So where's the 8 in column 7? It has to be here. So this is 8. And that's even. Where are all the 8s then? 8 has to be one of these two. 8's one of those two. 8's one of these two. 8's one of those two. We don't have any Knight's Move to help with that, so we're sort of stuck there. Where is 6 in column 8? Can't be here because of 6 in the boxes. Can't be here because of 6 in the row, so it must be one of these two. That means this has to be odd because it cannot be 2, 4, 6, or 8. This has to be odd because it can't be 2, 4, 6, or 8. This 3 is odd, obviously. We have 5 odd digits in row 4, which eliminates odd digits in the rest of the row. So this is even, and this is even. This can't be 7. This is 4 or 8. This is 4 or 8. Interesting. We have a 4-7 pair in row 7, which eliminates 4 and 7 in the rest of the row. That leaves just 3 and 9 in that row. So this can't be 3 because of 3 in the column. So this is 9, this is 3, and obviously this is odd. This cannot be, well, it could be 4. So that's fine. Okay. 2, 7, and 9 all have to be here. So this cannot be 7 here. Because these two cells sees this cell's by anti-knight. This cell sees that cell by normal Sudoku being in the same column. So this cannot be 7. This cannot be 3 or 9. It's 1, 5, or 7. Okay. 1 and 7 are both here. They are both a knight's move away from this cell and this cell. So this cannot be 1. It's 3. This can't be 7. So this just can't be 7 here. Anyways, this 3 eliminates 3 here. So this is 1, which eliminates 1 here. So it's 3. This obviously can't be 3 anymore. This is an odd digit. 3 eliminates 3 here, so this is 5, which eliminates 5 here, so it's 3. Where is 5 in row 4? Can't be here because of 5 in the box. These are filled in. This is an even digit. This is an even digit. This is sees a 5 there, so 5 has to be here. Okay. 5 has to be one of these two digits here in column 5. And we don't know about this. Could be any of these, so it has to be one of these 3. Both of these 5s see this cell, this one from normal Sudoku, this one from Knight's Move, so this cannot be 5. We have a 4-7 pair now in column 7, which eliminates 4 and 7 in the rest of the column. This can't be 4, this is 5 here. So we can remove 5s in these cells here. This can't be 5, it's 1 or 7. This is an odd digit. This 5 eliminates 5 from being here. Remaining digits in this upper central box are 1, 4, 7, 9. This can't be 9 because of 9 in the column. Also, in column 4, we have 1, 4, or 7 remaining. This 1 is a knight's move away from here, so this can't be 1. We have a 4, 7 pair in column 4, which eliminates 4 and 7 in the rest of the column. This can't be 4 or 7, it's 1. So that means this can't be 1 here. This 1 eliminates 1 being here. 3 cannot be here because of 3 in the row. So we're guaranteed a 3 here. This has to be 1 or 7 as the remaining odd digits in row 4. This is odd, obviously. 9 is guaranteed to be one of these 2 digits here, which eliminates 9 in the rest of the row. So where is 9 in this upper right-hand box? It has to be here. So this is 9 there. Where is 9? 9 in this lower central box. It has to be here. Okay, that's not helpful. Remaining digits in this lower central box are 1, 3, 5, and 9. 3 and 9 cannot be here, so this must be a 3, 9 pair here. So this has to be 5 here, and this is 1 here. So 1 eliminates 1 here, so it's 7, which makes this 1. 7 eliminates 7 here, so it's 1, which eliminates 1 here, so this is 3. That means this can't be 3, and this can't be 1. So this is a 4, 8 pair, which are both even, which eliminates 4 and 8 in the rest of the column. And box, so this can't be 4, it's 1, this can't be 4, it's 3. So these are both odd. We are guaranteed one of these is a 4 then. Okay. Remaining digits in... We have a 4, 6, 7 triplet in row 9. So this cannot be 6. That leaves the remaining digits as 1 and 5. They're both odd. And this must be a 6 then, because that's the only place for it in that box. 6 eliminates 6 here. One eliminates 1 here because of knights of anti-knight. So this because that's a knight's move away. So this is 5 and 1. 5 eliminates 5 here, so this becomes a 7-8 pair, which eliminates 7-8 in the rest of the column and box. So this can't be 7, this is 1. This can't be 7, it's 5. Remaining digits in row 5 are 7, 8, and 9. This is 7 and 9. This is 7 or 8. The remaining digits in column 9 are 4, 7, 8, and this can't be 8 because of 8 in the row. This 4 is a knight's move away from this cell, so this can't be 4. This is 7, this is 4. 7 eliminates 7 here, so it's 4 and 7. 7 is a knight's move away from this cell, so this can't be 7. This is 4, which makes this 8, which makes that 7. 8 eliminates 8 here, so it's 4. 7 eliminates 7 here, so it's 9. This can't be 7 or 9, it's 8. 4 eliminates 4 here, so this is 7. 7 eliminates 7 here, so it's 9. No 9 here. Remaining digits in row 6 are 2 and 6. Okay, that's not helpful. 7 eliminates 7 here, so this is 6 and 4. 6 eliminates 6 here, so it's 2 and 6. 2 eliminates 2 here, so it's 7 and 2. 4 eliminates 4 here, so it's 7. 3 here eliminates 3 here, so it's 9 and 3. 9 eliminates 9 here, so this has to be 9. And we know how to do knight's move. 4 eliminates 4 here by knight's move, so this is 8 and 4. 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 4 and 7. And that's the solution. Yeah, I'm not very good at knight's move, so that was... it takes me a little longer to see these anti-knight synergies. Usually other people are much better at it than I am, so... If you got that much faster than me, good on you. You're probably just better at anti-knight rule set than I am. So I mainly did this because of I was curious about the offset quadruples, and just to see what it was like. It's a nice little rule set. It's just another tool in the toolbox for setters, and it makes things interesting for them, I guess, which is cool. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.